Unless you have been living under a rock for the last few years, you have definitely heard of the word Bitcoin. Once you start reading articles about Bitcoin, it doesn't take long before it mentions the word blockchain technology. So what exactly is the blockchain technology? The blockchain is a digital ledger or shared database. This digital ledger is the chain, and every time new data entries are added, these are all called blocks. They get added in order periodically as it updates and forms the blockchain. It is the backbone of every cryptocurrency, though its long-term applications likely include much more than just digital currencies. In theory, this digital ledger could be any shared database used to store any information, but in the case of Bitcoin and basically every other cryptocurrency, it is a digital ledger used to keep a record of transactions for the network. So how does it work? Specifically, in the case of Bitcoin, each block on the blockchain holds transaction data, a timestamp, a unique hash reference, and the unique hash reference of the previous block. This data creates a chain of blocks that proves the accuracy of its records. The timestamp proves that the transaction data was published before the block got its hash. This hash is used to confirm the block's authenticity, and by having the previous block's hash, it can also begin to form a chain that cannot be edited once published, as to edit would require editing every computer holding the Bitcoin ledger. Although new to us, the concept of blockchain actually has its origins in 1982 and was adapted further in 1991, before being used by Satoshi Nakamoto, the mysterious founder of Bitcoin, in 2008. But hold on, what do I mean by digital ledger exactly? A ledger is a book of monetary transactions, a list of credits and debits for a business or individual. A digital ledger is just one kept on a computer rather than in a physical book. The list of transactions is what secures the cryptocurrency's value. It makes their value provable rather than speculative, having finally found a solution to the double spend problem faced by all forms of digital currencies before Bitcoin. Before the invention of Bitcoin, all electronic forms of currencies failed, as there was no way to ensure someone did not spend their electronic currency twice, as information is a lot easier to reproduce and forge than cash or gold. This is known as a double spend problem. The concept of a digital ledger that was continually updated, shared and agreed upon by most nodes in the network finally solved this problem by requiring all those who want to mine Bitcoin for its reward to hold the full copy of its digital ledger. It removed the possibility of the double spend problem, as to cheat the ledger would require cheating more than half of the network. Simply put, if a Bitcoin has been spent, there is a record of that. Even if that Bitcoin is just sitting in a wallet, there is a record of that too. The more people who hold this digital ledger, the more it can be cross-referenced to ensure its accuracy when new transactions are submitted, making it harder for an individual to submit fraudulent transactions. Unless an individual controls 51% of the entire Bitcoin mining network, they cannot successfully submit false transactions. This is also known as a 51% attack, and on a network as large as Bitcoin would require an immense hacking operation, beginning at the same time across hundreds of thousands of computers all across the globe, meaning that at this point it's unlikely to occur for Bitcoin without some significant advance in technology first. Let's now see what crypto mining is. Crypto mining is a process by which Bitcoin and other cryptocurrencies release new coins and verify their transactions. This is achieved by those who lend their computing power to verify incoming transactions, being rewarded with newly created Bitcoins as a reward for doing so, creating a positive cycle of miners securing the network through authenticating its transactions and creating new Bitcoins, which they are then rewarded and can sell for profit. However, mining only applies to proof-of-work cryptocurrencies. there are other consensus mechanisms to verify transactions, such as proof of stake, which Cosmos uses, or proof of authority, used by VeChain, but those are topics for another time, so make sure to subscribe. How is all of this secure exactly? Looking at Bitcoin, as we just mentioned, requiring a consensus of 51% of the overall network means that if you upload a false transaction, you need to get a majority of the network to agree that it is correct, which, when there are hundreds of thousands of computers independently connected around the world, seems unlikely. Making it harder, all of those computers are decentralized, meaning they do not report or belong to one centralized server. This is because in a decentralized setup, all the participants are disconnected from each other, running their own machines in their own buildings. If you take down one server, the rest still exist, holding and hosting a perfect copy of the entire blockchain history. Though it is worth noting that some cryptocurrencies swap this extra security that decentralization provides for speed, and as a result, they are either fully or partially centralized. As if that wasn't enough, once a block is added to the blockchain, it is hashed in such a way that makes changing it impossible. Since every computer holds a copy, it can't just be opened and edited, the same way you cannot submit a fraudulent transaction. Once published, it becomes public knowledge, screenshotted, and immortalized. That's not even mentioning the high-level SHA-256 encryption that secures every entry on the blockchain, which is some of the toughest encryption on the planet. SHA-256 is so strong that even with the significant financial incentives for doing so and zero regulation preventing it, Bitcoin's encryption hasn't been hacked or corrupted in the 13 years Bitcoin has been active. But what exactly are the benefits of using the blockchain? The main benefits of blockchain technology are transparency, data permanence, and servers that do not go offline. Although we have mostly talked about Bitcoin, blockchain technology has begun being used in multiple other applications other than crypto. For example, when we think of blockchain again as a shared database instead of a digital ledger, we find it is already being used to track students' academic progress in developing countries, track and discover the location or information about items in mass storage, or ensure the quality and authenticity of inventory items in transit. When we look at blockchain technology, you could pretend we are looking at the original Atari games console. Blockchains currently are an early prototype of an industry that looks set to expand as the years progress, with how exactly this technology will be used not being fully realized yet. In conclusion, what is the blockchain? The blockchain is a shared digital database mainly used to verify cryptocurrency transactions. It offers a permanent record that cannot be edited, manipulated, tricked, or conned. It does this by requiring everyone running the network to hold a complete copy of the whole network, meaning if one server goes down, the network does not. Although currently mostly crypto-focused, the technology itself can be applied almost anywhere. For example, I like to imagine a world where government spending is processed through a publicly viewable blockchain, so we can see exactly where it all goes. But maybe I'm just dreaming.